This is the last video for the supplement to Chapter 6. The last topic we need to talk about is capability. Now that we've talked about control, if the process is in control, and it depends on what type of data we're looking at. If it's continuous data, of course you have to do an X bar and an R chart. You have to look at both the mean, the average, and the range because it's continuous data, or what your textbook refers to as variable data. If you have a percentage, you don't have an R chart because you don't have a range, you just have the average percentage. And so we look to see that the average percentage is staying in control. With a C chart, you don't have a percentage, you just can count up the number of errors or complaints. And so we can create a C chart. And there's videos for all of these different charts and how to create the upper and lower control limits and how to go about graphing those or creating a chart if asked to do so in Excel. The last topic we need to talk about is capability. Once the process is in control, is it capable? Is it capable of reaching our target? Now there are two ways, and both these formulas will be presented to you. Capability by itself assumes the process is somewhat balanced, so that our means match up and that our desired specification, those means match with our process. If that's not the case, if there are differences, then you really need to use the index, the CPK, instead of the CP, which is just a measurement of capability. I'm going to use data from 6.27. We're producing computer chips here, and the only thing they've given us is the upper and lower specifications. So these are the design or the desired performance. Remember, they can refer to these many different ways, but they want their hope is that their chips last 2,400 hours and the least amount is 1,600. Well, our process, our average chip is 1,800 hours. Now, they haven't told us what the mean is, and so we just can assume that we're matching the average, and you can see that we're not balanced here. And so the capability measurement just would not work in some sense, in that we're allowing our desire is 600 hours, so the difference between 2,400 hours, the upper specification or mean of our process is 600 hours, that it can be as much as 600 hours more, but only 200 hours less. So it's not balanced. So it would be more appropriate to look at the upper end and then the lower end. And so both the capability formula and the capability index will be on the formula sheet, but in this case, because it's not balanced, you'll want to do the capability index. And so that formula, you simply take the upper specification and you subtract the mean in this case, and then we're going to divide it by three times the standard deviation of our process. It's not 6 like in the capability, because we're not looking at the difference between the upper and lower and then our standard deviation, because our mean is not balanced. In this case, we have a difference between the upper and the lower, and so we're only looking at the upper part, which is 3 standard deviations, and then we'll look at the lower part, which is 3 standard deviations. And so we wind up with, at least on the upper end, a capability index of 2. So this is very capable. In fact, it reaches the 6 sigma. Remember, the goal is at least a 1. That means capable, just barely capable. We really want a 1.33 at least. And a 2 is the 6 sigma standard, which is a higher level. We're half as small as we need to be. But let's look at the lower end now. So the lower end, we start with the mean and subtract out the lower specification. So how far down we're going to go, the difference between 1,800 and 600. So this is only going to be 200 hours, so it's a much smaller range that we're willing to go down. And then, of course, we divide that by the same amount of standard deviation, so 3 times the standard deviation in this case. And so with the capability index, you actually get 2 calculations because if they were balanced, the answer would be the same for both the upper and the lower, and that answer would also match the capability formula. But because they're not balanced, we need to do the index for sure here. We get 2 different answers, and they tell you to look at the minimum one because both of these have to be capable for the process to be capable. And so looking at the smaller one, we know that the upper is very capable, but we would say this process is not capable because on the lower end it's below 1. So we're not producing within the desired specifications, is that we're a little low on the one end, that we hope that our average would have been a little higher and maybe a little bit more balanced. And so this process is not capable.